Hi folks, my name is Ravi Prakash and we are doing time and distance, and this is the last topic of time and distance, boats and streams, right? Very important, boats and streams. We'll discuss all the concepts and questions. Okay, let's start. Boats and streams. Okay, see here, it's like the river flowing like this. Okay, a boat is on this, right? Speed of boat is, let's say, SB. Speed of river is SR. Okay, so SB here is speed of boat. Okay, speed of boat, and SR here is speed of, it is called speed of river, it is called speed of current, it is called speed of stream, right? They call anything. Okay, so SR is speed of river or current or stream, right? This is SR, the speed at which river is flowing, and SB, right? So there can be two ways, right? Either the boat can go with the stream, and either the boat can go against the stream, right? So when the boat goes, okay, if the boat is going with, or I should say, with the direction of stream, boat is going with the direction of stream, okay, it is called downstream. Okay, it is called downstream. With the direction of stream, that means downstream, right? Against, okay, when the boat is going against the, when the boat is going against the direction of stream, it is called upstream. It is called upstream, right? So quite logical. When you're suppose you're swimming, and when you're swimming with respect to water, you're going downstream, you're going faster, right? Because there's something you're swimming is speed, something is the river speed, both will be added. Okay, and when you're swimming against the stream, right, you're going slower, that is upstream, right? You're going up the stream. Okay, against the stream you're swimming. Okay, that is called the upstream. Fine. So what is downstream speed here? You see, so downstream speed here is obviously SB plus SR, right? Mark it, equation number 1. SB plus SR, downstream speed. Speed of boat or speed SB, right? Speed of man you can take. Speed of man or the person swimming or the boat, anything, right? Whatever is the actual speed, right? Suppose I am swimming at the rate of 10 meter per second. So my SB, so I'll call SB as 10 meter per second, right? So SB is speed of boat. In that case, suppose man is swimming, the speed of man. Okay. So speed of boat, suppose boat is going at the rate of 20 meter per second and river is flowing at the rate of 5 meter per second. So effective speed of boat is what? 20 plus 5, 25, because boat will go faster because it is going with the stream. Okay, so SB plus SR. Similarly, speed upstream is equal to SB minus SR. This is second equation. Obviously, speed upstream is SB minus SR because suppose my boat is flowing at the rate of 20 meter per second and river is flowing this side at the rate of 5 meter per second, right? That means if I'm in 1 second, I'm going 20 meter ahead of my boat with my boat, but river is pushing me 5 meter back. So 20 minus 5, what is my effective? Effective 15 meter. So in 1 second, I'm going 15 meter only. Okay, so that means what is upstream speed? SB minus SR. Okay, now if you add these two, right, you see, adding, what you will get when you add 1, 2. So adding 1 and 2, what will you get? So once you add 1 and 2, SR will get cancelled. Okay, so you'll get SD plus SU is equal to twice of SB. Okay, therefore you get SB is equal to SD plus SU by 2. That means what is speed of boat in terms of downstream speed and upstream speed? So it is the average of upstream speed and downstream speed, right? That is simply SD plus SU by 2. Speed downstream plus speed upstream by 2. Okay. Similarly, on subtracting 1 and 2. Okay, subtracting 1 and 2. What you will get? So you'll get, you say subtract 1 and 2. this SB minus SB will get cancelled, so it becomes twice of SR is equal to SD minus SU. Okay, therefore you get SR is equal to SD minus SU by 2. Okay, you get SR is equal to SD minus SU by 2. Very clearly here, SD minus SU by 2. So SR is equal to SD minus SU by 2. Okay, so I'll write these 2 important points here in the next slide. That SB, speed of boat, is equal to upstream downstream speed plus upstream speed by 2. Correct? And what is and when you subtract those two, right? When you subtracted these two, it came speed of river. What is speed of river? Downstream speed minus upstream speed by 2. Got it, right? And it was like, what is downstream speed? It is SB plus SR. Is speed of boat plus speed of river. What is upstream speed? SB minus SR. Speed of boat minus speed of river. Okay, so very important point. Now, one again very important point here is application of AM and HM. Okay, we have discussed it, right? We discussed it right from the first video, right, about AM, HM and its application in time and distance chapter, right? So we discussed how to apply when speeds are in AP, right? So it's reciprocal is time when distance is constant. So speed reciprocal is time when distance, that means speed is inversely proportional with time. Okay, when distance is constant. So if one parameter is in AP, other parameter has to be in HP. We had discussed it, right? So similar application in boats and streams. Why in boat and stream? Because same thing. See, while going downstream speed is what? SB plus SR. Now, with if in still water, okay, in still water, what is the boat speed? It will be SB, and upstream speed, that is against the current, right? It is how much? SB minus SR. You can see here that SB plus SR, SB and SB minus SR, they are in what? The speeds, downstream speed. That means speed of, this is what? This first one is speed of boat with stream. Speed of boat with stream. What is second one? Speed of boat in still water. Speed of boat in still water. And what is third one? Speed of boat against stream. Speed of boat against the stream. Right? You can see here, this speed of boat with stream, speed of boat in still water, and speed of boat against the stream, that is SB plus SR, SB and SB minus SR. They are in AP. They are in arithmetic progression. Right? So SB plus SR, right? SB and SB minus SR are in arithmetic progression, right? So when distance is constant, that means it's what is inverse of speed? Time. That means time will be in all these periods will be in HP. That is harmonic progression, right? HP is harmonic progression. Okay, so time in all these periods will be in HP, right? Suppose that means if time taken here is, let's say, a speed is going downstream and it completes a distance in a second. In still water, the same distance is covered by boat in B seconds, and in upstream, the same speed is covered in C second. Same distance is covered in C second, right? Suppose in river, you are going from one end to other end. With a stream, it takes you a second. in still, when the water is still, right, then you calculate the time to reach this between these 2 points, it is b second. And when it is against the stream, let's say it is c second, we are going like this, you're going like this, and the stream is like this. So when against the stream, it is going in c second. So these three are in HP. That means what? That means B is the harmonic mean of A and C. That is B is equal to 2AC by A plus C. A very important point. This point we are discussing speed and time normally. Then we discussed in man and escalator. Okay, and then we discussed in boats and stream. Same funda, right? Very important point. So you can solve the questions very quickly. See here, question. If boat is traveling upstream, it will reach the destination in 40 seconds. If boat is traveling downstream, boat will reach the destination in 60 seconds. How much time boat will take to reach the destination if it travels in still water? If it travels in still water, right? Again, a simple application of that funda, right? Upstream, it is in 40 seconds. Okay, so it is like downstream, it is in 60 seconds. Upstream, it is in 40 seconds. And still water, we have been asked for. I know that these three are in speeds. I know these three speeds are always in HP. Last slide we discussed it. So these three speeds are in AP because SB plus SR, SB minus SR, and SB plus SR. This is only SB. In still water, only SB. And this is what? SB minus SR. So these three are in AP. Therefore, time will be in HP. So simple I can do. I have to calculate B here. I have to calculate B here. A is given as 60 seconds. C is given as 40 seconds. So B is equal to 2AC upon A plus C. Right. That is 2 into 60 into 40 upon 60 plus 40. That's it. What is the answer? 48 seconds. So answer for this question is 48 seconds. This is the answer. Answer for this question is 48 seconds. Right. These three time will be in harmonic progression. That is in HP. So when three terms are in harmonic progression, for three terms, the middle term is the harmonic mean of the other two. Okay. Very good concept. Very good concept. Answer is 48 seconds. Okay. Next one. Now I'll do some easy problems here. Then we'll move to difficult problems. A boat travels 48 km upstream in 8 hours and 36 km downstream in 9 hours. Find the speed of boat in still water and the speed of water current. Right, we'll do this with this very easy problem. We'll do some easy problems and then we'll move to some difficult problems. Okay. So a boat travels 48 km upstream in 8 hours. What is the speed of boat upstream? So speed upstream is how much? 40 is speed is distance by time, right? So 48 km by 8 hours. Okay, how much it is? The speed upstream is 6 km per hour. What is speed downstream? So speed downstream is how much? 36 km in 9 hours. That is 36 km by 9 hours. How much it is? It is 4 km per hour. So you have this speed upstream and you have the speed downstream, right? Two things you can calculate easily from here. What are the two things? Speed of boat in still water and speed of water current, right? We have just studied it. Okay. Yeah. So what is now speed of what is the speed of boat here? So speed of boat is what? It is SD plus SU by 2. So SD plus SU by 2, right? It is 6 plus 4 by 2. That is 5 km per hour. Okay. And what is SR? It is the difference of these two, right? Difference of these two. So obviously in this case, speed this is greater, right? SU. So simply you should take here SU minus SD. It should be right. See, it could be. Okay, this is the next question here. A boat travels 48 km upstream in 8 hours and 36 km downstream in 4 hours, right? Find the speed of the boat and in still water and the speed of water current. Okay, so it's an easy question, right? We'll slightly do easier questions at first and then we'll move to difficult question, right? So this is quite easy question. I hope you can do it easily. See, so from here I can get what is upstream speed of boat, right? So upstream speed of boat SU I can get here 48 km upstream in 8 hours. Speed is distance upon time. 48 by 8, 6 km per hour. Okay. Now speed downstream 36 km downstream in 4 hours. So 36 km downstream in 4 hours. Okay. How much it is? 9 km per hour. Okay. So what is SB I can get? What is SB? So SB is, we know, SD plus SU by 2. Okay. That is 9 plus 6 by 2. That is 7.5 km per hour. Okay. So SB is 7.5 km per hour. Okay. Now SR I need to find, right? I need to find the speed of water current also. What is SR here? So SR I know is SD minus SU by 2. SD minus SU by 2. That is 9 minus 6 by 2. That is 1.5 km per hour. These are the answer for this question. Okay. Quite simple. SB is SD plus SU by 2 and SR is SD minus SU by 2. Okay. Move to next question now. A boat can travel 1.5 times the distance down the stream than up the stream in the same time. Okay. If the speed of the current is 8 km per hour, find the speed of boat in still water. Okay. So the boat can travel 1.5 times the distance down the stream than than up the stream in the same time. Right? Time is same here. So we have to mark it in this cases. Time is same. Okay. So when time is same here, okay. So distance, I can write here that distance downstream is 3 by 2 of the distance upstream. Okay. Distance downstream is 3 by 2 times of distance upstream, right? That means basically distance upstream upon distance downstream. What is the ratio? It is 2 by 3. So now here comes this very important concept. We discussed a lot in races and all, right? About this concept. When time is constant, time is same, that means time is constant. So when time is constant, distance is directly proportional to speed. Okay, that means ratio of distance is equal to ratio of speed. So I can directly replace it with distance upstream upon distance downstream is 2 by 3. Therefore, speed upstream upon speed downstream is how much? Same thing, 2 by 3. Okay, speed upstream upon speed downstream is how much? 2 by 3. Right, very important point we got here. So from next, I can easily solve it now. What is speed upstream? It is SB minus SR. Okay, so it's like SB minus SR. So SB minus SR upon SB plus SR is 2 by 3. Okay. And I know what is the value of S, right? The speed of current is 8 km per hour. Okay. So SR is 8. Simply put 8 here. SB minus 8 upon SB plus 8 is equal to 2 by 3. That's it. We can solve it to get this as SB equal to 40. Okay. So SB I can solve it to get 40 km per hour. So speed of boat in still water is how much? 40 km per hour. That's the answer of this question. So that concept again, right, we can use here that when time is constant, distance is directly proportional to speed. Right. Okay, next one. A man can row 2/7 of a kilometer upstream in 25 minutes and return in 10 minutes. Okay. Find the speed of the man in still water. Okay, 2/7 of a kilometer upstream in 25 minutes and return in 10 minutes. Okay, so I want to convert this question, right? So either I can convert this question to kilometer per hour or I can convert this question to meter per second, right? Your wish, right? Let's convert to kilometer per hour. Okay, so a man can row 2/7 of a kilometer upstream in 25 minutes for this part. Okay, that means what is speed upstream? So distance upon time. What is distance taken? 2 by 7 of a kilometer. Fine. Upon speed. Sorry, upon time taken. What is time taken? 25 minutes. Change to hour. 25 by 60 hours. Right. How much you get here? Solve it easily. 2 by 7 into 60 by 25. Correct? 5 goes 12 times, 5 goes 5 times. That's it. 24 by 35 kilometer per hour is the upstream speed, right? Then downstream speed. So he returns in 10 minutes, right? So 2/7 of a kilometer, he returns in 10 minutes. So again, distance is 2 by 7 kilometer. What is time taken? 10 minutes. That is 10 by 60 hour. Okay. So how much it is? 2 by 7 into 60 by 10, right? Cancels 5 times. So you get 60 and you can again cancel here, right? Here. 5 goes 12 times. So it is 12 by 7 kilometer per hour. So I need to find what is SB here. So what is SB? Right, I need to find the speed of man in the still water, right? SB or SM, I told you same thing. You can take one variable. SP is the actual speed of boat in water. So you have to find the speed of man in still water. That means I have to find the speed of the man in still water. That means actual speed of man. So I can find, okay, SB is equal to SM. That is speed of man is how much? SD plus SU by 2. SD plus SU by 2. That is 24 by 35 plus 12 by 7 by 2. You can solve it. You can take 35 is the LCM here. Okay, this part. So I'll solve it, no issue. Let's solve it. Take 35 is the LCM. So 35 is the LCM. 24 plus 60. Okay, upon 2. So you get here 84. Okay, 24 plus 60, 84 by 70. That is 6, 14 6, 14 5. Okay, 6 by 5 kilometer per hour. That is the answer. That is the answer for this question. 6 by 5 kilometer per hour. Right? I hope it is correct. Okay, 60 by 35, 84 by 35, 85, 70. Yeah, correct. Fine. 6 by 5 kilometer per hour is the answer for this question. Find the speed of man in still water. Right? Still we are doing some easy questions here. Just get in groove with time and distance chapter. Okay, just get in the groove. Yeah, this one now. Speed of the boat in still water is 30 meter per second and speed of a stream is 18 meter per second. Okay, if boat is moving upstream and again downstream, what is the ratio of the time taken to cover a particular stretch of distance in each direction? To cover a particular stretch of distance in each direction, right? This times it shows that to cover a particular stretch of distance in each direction, it shows that, what does it show? It shows that distance is constant. It shows that distance is constant. That means speed will be inversely proportional with time. Correct? Okay. So now speed of boat in still water is 30 meter per second. So I can write SB is equal to 30 meter per second and SR is equal to 18 meter per second. That is the speed of current. Okay. So what is here? I can get from here, what is downstream speed is SB plus SR, 30 plus 18. That is 48 meter per second. What is upstream speed? SB minus SR, 30 minus 18, 12 meter per second. Okay. So what is the ratio of the time taken, right? So if boat is moving upstream and again if the river is coming like this, if the boat is moving upstream and then downstream. Okay. So what is the ratio of time taken? Okay. So ratio of speeds here, I can simply write here quite easily that ratio of speeds is how much? 48 and 12, right? 48 and 12. That is ratio of speeds is 48 is to 12. That is 4 is to 1. So if ratio of speeds is 4 is to 1, okay. So ratio of speeds is 4 is to 1. Therefore, ratio of time taken will be how much? Ratio of time taken will be how much? Right, speed is inversely proportional to time because of distance being constant, right? It is written there to cover a particular stretch of distance in same direction. That means distance is both in same the cases. While going upstream and while coming downstream, distances both in same distances same in both the cases. That means ratio of time taken will be inverse of ratio of speed. Okay, so how much it is? 1 is to 4, right? Should be like written 1 by 4 is to 1. That is 1 is to 4. This is the answer for this question. 1:4. Okay, so this kind of small concepts, right? It really helps. Okay, move to next question now. A boat takes a total of 6 hours to row 8 km downstream and to return back to the starting point. If the speed of the boat is 3 km per hour, for how much time was the boat moving downstream and for how much time upstream? Okay, fine. Similar question again. So I know that total time taken in this case is 6 hours. Okay, so time taken upstream always would be greater than time taken downstream for sure, because if obviously when distance is same, so if you're covering same distance and same distance in both the parts, right, upstream and downstream, so obviously time taken upstream will be always more than time taken will be downstream, because downstream your speed is faster, you're coming with the current. Upstream you're going against the current, right? That means the speed is slower. So total time taken is 6 hours. So what is time taken upstream? So time taken upstream plus time taken downstream is equal to 6 hours. What is distance covered? 8 km. Okay, 8 km downstream and as well as 8 km upstream. So 8 km by upstream speed, right? What is upstream speed? It is, so upstream speed is what? It is SB plus SB minus SR, right? What is SB here? It is 3. Okay, it is 3. So it should be 3 minus SR. Okay, so 3 minus SR plus okay, 8 upon, similarly 3 plus SR. What is downstream speed? So downstream speed is SB plus SR. SB given as 3, so it is 3 plus SR. 3 plus SR. So 3 plus SR is equal to 6. Is equal to 6. Right, now you can solve it. Okay, so on solving, see, there's 2 ways to go from here, right? A bit of complex solving it is, so no issue. First way is take the LCM. So 8 into 3 plus SR plus 8 into 3 minus SR upon 3 minus SR into 3 plus SR is equal to 6. Right, so solve from here that 24 plus 8 SR plus 24 minus 8 SR is equal to, this is right, this is what, this is 6 into, now A plus B into A minus B, right? So 9 minus SR square. So you can solve here. So you'll get SR ultimately as 2 km per hour. You can solve it now. SR you'll get as 2 km per hour, right? But from here, the other way is to going by options, right? The other way is to going by options. You can go from options here, right? Options are given as A is 2, or B is 3, or C is 1, or D is 4, right? So you can see for options here, right, which option is matching. Okay, easily you can see, right? Suppose you put 2, I know 2 is the answer here. If you put 2 here, sorry, not 2, SR will get something as 1, I think, not 2, I'm sorry. Yeah, SR will get as 1. When you solve, you get SR as 1 km per hour. Okay, so I know 1 is the answer. So suppose you put 1 here, so what will happen? You can do it quite easily, right? If you put 1 from here, so 8, it should be like what? It should be like 8 by 2 plus 8 by 4. If you put C option SR as 1, 8 by 2 plus 8 by 4 equal to 6, correct? 8 by 2 is 4, 8 by 4 is 2, 4 plus 2 is 6, correct, right? So 1 is satisfying, so 1 is the answer. Okay, so from, rather than solving this step, right, not needed this much. If options are there, not needed. Okay, directly you can get to SR as 1 km per hour, correct? Okay, now next question, or the next question we'll do in next video. Okay, there are a few more questions we'll do in next video. Okay, thank you.